Welcome to The Curious Developer. I'm Jesper Pedersen from KDAB. Sometimes when I'm sitting there and my program is compiling or I have an error message I don't really understand, my brain starts drifting off and I will be asking myself a bunch of questions. Why do people that do not necessarily love Qt, why do they not at least love the signal slot and the introspection available? Or is it possible that one day we'll see a future where we have exception handling in Qt and Qt smart pointers and possibly even import Qt? And I'm sitting there 10 minutes later looking at the same compile error and it doesn't make any sense because it's on a blank line that it's complaining there's something wrong. Then my mind starts drifting really off and I'll be asking myself questions like, if Bjarne Stroustrup was a superhero, what kind of hero would he be? Unfortunately, today I have the great honor to ask all of these questions and many more to Bjarne Stroustrup. Bjarne, welcome on the show.
Oh, thank you.
It's a pleasure to have you here. And let me just help you out with the first one, because I know that Bjarne is not too keen on telling which kind of superhero he would be, but I know he would be Superman, because he has the ability of looking at the very details and understand all the odd implementation details of C++ and still keep an eye on the overall picture.
I'd just like to point out that I do know how to put my underpants under my pants as opposed to Superman.
Fair point. So with that leads me to the first question. How do you keep, C++ is a huge language these days and there's lots of tiny details. Do you never get in a situation where you sit there with a new feature or improvement in mind and it violates something you absolutely did not think of?
That's not quite the way I think about it, but obviously I can't keep everything in my head at once. I meet these usually young programmers who says, I want to know everything. No. You wouldn't be such a good developer, you wouldn't be such a good programmer or scientist if you tried to know everything at all times. You have to keep the big picture in your mind. You have to focus on something specific. And you can always pick up all the details necessary once you are in the right place. But what people lack very often is the overview. They can't pick the part of the language that would help them. So you have people writing C-style code where they should write object-oriented code, and your people write big class hierarchies when they should be doing generic programming, or as you said, writing a lot of error codes and forgetting to test them when they should be using exceptions.
Yeah.
So you need the overview, you need the underlying philosophy, and then, there's CPP reference on the web that'll give you the language and standard library details. Qt has a bunch of web pages that get you the details. I don't remember what all those parameters are all the time. That's what you've got reference material for.
Yeah.
There was some British philosopher about 400 years ago who pointed out there's two kinds of knowledge, what you know and what you know how to find.
Fair point.
And I think that's a very important point, especially today where we are overwhelmed by information, and people lose track of the important things. They can't see the forest for the trees, and you have to focus on design philosophy, on fundamental facilities, not on all the details.
But that is sometimes also the problem when you get into a new language. I mean, if you get into the right way, so to speak, where you read the right books rather than just, I mean, a lot of us learn new stuff from the internet, and just, if the first thing you see is a deep class hierarchy, then you think that must be the way to do it, and then it's difficult to get to the overarching.
It is, and you have to describe things. There's several problems with the online stuff. First of all, it's not all right. There's a lot of people who want to get famous by being seen on YouTube, and no, you should write things, you should video things, whatever, when you have something to say and when you have thought it out, and quite often when you have tried it out on somebody to see if it made sense. So I write articles and I write books, but only when I feel something needs to be said.
Right.
And I wrote the very detailed stuff 20 years ago. Nowadays it's more like the overview. A tour of C++ is 256 pages. You can read it in a weekend, but it is aimed squarely at people who know how to program already. It's not the beginner thing.
Right.
So I sometimes get criticized for, but it's not for beginners. No, it's not for beginners. Or, but it doesn't explain everything. There's not enough. No, I wrote another book that has enough. And anyway, there's a lot on the web. And I have another book that I wrote for beginners to start teaching first-year university students about how to program.
Yeah. And then another problem with things on the web is that it doesn't age well, all of it. I mean, you would sometimes wish that there was an automatic deletion of things on the web after a certain period, and I mean that's one of the problems we have with C++, for example, that people is getting expired from things that was written 20 years ago.
Yeah, they're stuck, and there's problems. People on the web, by and large, doesn't explain problems. They like to hype something. Right. And they like to hype something new. So one of the problems with C++ and every other language, as far as I know, is that people like to show how clever they are. So they want to show advanced stuff. And when novices bump into that, they quite rightly get very annoyed.
Yeah.
So we need to get the overview. We need to get the fundamentals in place, and then we can dig in.
Yeah. And digging in is what we'll try to do today. If you just joined here and wonder what is this Jesper character talking to Bjarne about, and I am now here at Qt World Summit 2025 in Munich, and Bjarne was one of the keynotes there, and he was very kind to say yes to an interview. And exactly this is the key thing about what you're watching here, that I try to dig that level deeper and not just run around with hearsays. So Bjarne, I have 4 categories of questions for you. We have one that's called Bjarne, where I'd like to understand a bit of deeper of some things, because C++'s story is your story too. It was born almost with you. Give and take. It has been a long, very productive career you had there with C++. I have one with a few questions on the language and tools around there, and then in the end, we are at Qt World Summit, so people would lynch me out there if I didn't ask a few questions relating to Qt. So let's start with one of those that I have marked up as Bjarne. In the early days, you wrote a few books on C++. I have one of them at home. It's the 3rd edition of your first C++ book, but nevertheless, it has followed me my entire career. Till this day, you're still writing books, which makes me wonder, you must be a very contested person with the insight and with your contribution, that writing books must be doing something for you more than just producing a book.
It's okay. What keeps me going is the interesting applications that people do of C++.
Yeah.
And so I spend a lot of time going around, traveling around, talking to people to learn what they're doing, what problems they have, and trying out my ideas.
Mm-hmm.
And to do with that means that I end up giving talks, and I end up writing articles, some academic, some more sort of industrial or popular, and that follows and tend to focus on particular things. Mm-hmm. But one thing I observe again and again is that what people lack is not the detailed information. It is not the specifics, except for some very specific things that they happen to be doing. People doing graphics don't have the same problems as people doing databases. They don't have the same problems as keeping a piece of software running on Mars. Mm-hmm. They're different things that's specialized. But there's something in common.
Yeah.
They actually, in the examples I took are not random. These are done in C++. And there's things that are overlapping and things that aren't. So I get pushed to write the framework for people's understanding. Mm. And that's roughly what my books are doing. In the old days, there was only a couple of types of books. The one you wrote, the C++ programming language, was trying to teach people how to write C++. Mm-hmm. And it was the only book for that for a while. Yeah. And then there's the annotated C++ reference, which I had to sign a copy of today, which was the foundation of the standards committee, mm-hmm. which was basically what I wrote up in terms of definition and implementation techniques. Mm-hmm. The design and evolution of C++, which I also signed today, and you can still buy. It came out in '94 and it's still for sale. Yeah. That's sort of unusual for computing books. But that was written to document the design and evolution of C++. That's its title, Design and Evolution of C++. And people kept asking me about it. In the end, I wrote it. As a matter of fact, the C++ programming language was written because Alejo pointed out to me that I needed to write it because I was getting all of these questions. Mm-hmm. So I write things in response to needs. Mm. And the needs I find just now are rank beginners trying to write programs. I was asked to do that by the computer science department at Texas A&M, and I still get constant requests for that. I don't write no programming, I don't know C or C++ very well. How do I get started? Mm. And the answer is the Swan book. Yeah. That's what's on the front page, what on the cover of it. It's called Programming Principles and Practice Using C++. Yeah. And that's quite descriptive. And then there's a larger group of people who sort of have gone away from C++ or come back, or they've been stuck with C++ as it were 10, 20 years ago, and they need a book to bring them up to date, and they don't have much time because they're usually busy programming and such, and a lot of them has realized that what they find on the web is too specialized. Right. And so I wrote a tour of C++, started out as a couple of introductory chapters of the C++ programming language, and now has evolved into its own thing. Mm. But that's a short book aimed to be readable by a reasonably experienced programmer in a weekend. Mm. Mm. Yeah. We can argue about reasonably experienced, and we can argue about
weekends.
How many days and hours there is in a weekend. But it's not one of those books. It's one of those books.
Yeah. No.
And so basically, I respond to needs.
And you also still teaches new people C++ at the university.
I teach at the university. Essentially everybody in my classes know C++ reasonably well. It's a graduate and final undergraduate course.
They wouldn't dare going into your class and say, "Hey, I'm a Java programmer."
Well, some people do, and I don't like language wars, so they get away with it. And I learned something again. Trying to teach C++ to a Java programmer is not the same as trying to teach C++ to a C programmer, which used to be the case. Yeah. And now we get them in from JavaScript and Python and such. It's different. And teaching is one of the ways you learn. And teaching is getting ideas into people's heads. And you have to understand what's in those heads before you have a chance of getting something new in there. It's yes, I think that's teaching, and so teaching a variety of people is good. I also spend a fair amount of time talking to people in industry or professors at other universities and PhD students and such. But that's something I've always done because I realized that very early on that I needed interaction with people to basically understand what's the problem. If I want to help people write good software, I have to understand what they're building and some idea of what is good. And that takes time, takes travel. I was asked earlier today if I traveled a lot, and I thought about it. I probably travel every second month at least and visit 1, 2, 3 times each. So I must have visited 400, 500 organizations over the years, and so I have a fairly broad view of what programming is and what C++ is and what works and what doesn't. And of course it's not perfect, but then no language is for everything and everybody.
I have a question that comes back to me from time to time. Like, I've seen many interviews where you tell that you started out with it's C with classes. And obviously, like anybody doing software development, you start out with something and it grows on you. And at what stage did you realize that, hey, I'm actually developing a complete new language here rather than just adapting for a few use cases around me?
Obviously, I was very busy. So I didn't realize it for a while. I was just building a tool for me. And then some of my friends started using it. C++ was used long before it was called C++. After half a year, I had a user who were not a tester who wanted it as a tool for something else. So this idea of getting feedback and seeing what worked and then improving things came in very early. C++ was designed to evolve. I realized that very early. I must say, probably after about half a year to a year, I realized that I was doing language design. And maybe 3 years in, I realized that it had to be different from C from a philosophical background. You still had to be able to do most C things because that's what the community was, that's what the tool chains were and things like that. But for instance, I tried to see if I could live with C function call syntax and function call semantics, which was basically you didn't know what the arguments were. And so I put in what is the current C function argument definition and checking. If you ever written a C program these days, you use the syntax I invented and some semantics I put in. And then you have C programmers complaining about me, but I don't understand. They're not complaining about the language they're using. They're complaining about the fact that there's more in C++ than they're using. But anyway, that was in about 83, and I got 10 years of complaints for incompatibilities.
Yeah.
You couldn't define square root without an argument and then calling it with an argument. I just couldn't live with that because I needed overloading, and I needed classes with well-defined interfaces. So even C with classes were more than C with classes. And in the early days, I couldn't convince the users that virtual functions were useful, so I had to force those in so that people could do proper object-oriented programming, which they didn't understand. But I've been taught it by Christian Nygaard, usually by sitting down over a beer. Also, I needed generic programming, and I thought I could do it with macros, and it didn't work. But sometimes it's better to have a problem than to think you have the solution. You must have the problem, because then you can solve it. You have to understand it.
That's the story of your life, really, isn't it? That you have this gradually improvement rather than reinventing everything, and here is the solution. I mean.
Yeah, I definitely, technically, I'm an engineer. I rely on feedback. Philosophically, I believe in evolution, not revolution, because revolutions tend to fail. Yeah. You can look at industry, or you can look at politics, history. So that's it. And then I realized that, I knew a lot of languages. So once I realized that a problem is genuine, I can look to theory and background and existing stuff and borrow things. I say borrow because I'm pretty good at acknowledging, as opposed to these people who says artists steal and pretending to be an artist. I already credited Christian Nygaard, right?
Yeah.
And did I mention Dennis Ritchie? Great guy.
Yeah. So, in the category of language, I would like to understand how you work when you develop C++. You have in many interviews said that you need to be proficient in multiple languages, and you need to understand the different languages. But what I at least have learned over the many years of software development is that one thing is to read a crossword and see that it's correctly filled out. The other is to sit there with a crossword and know what is the capital of whatever. And in terms of programming languages, how much do you do software development in other languages than C++? Or how do you approach these other languages when you try to get inspired from them?
Not as much as I should do, and probably not as much as I used to. I used to learn a new language every year. But for language design, actually the language is the last thing. The first thing is the problem.
Right.
I think every good language starts with a problem, and the same applies to every new feature. And I dislike fiddling with small things. You do that at the end.
Right.
You decide what is important. Generic programming is important. Error handling is important. Resource management is important. You have to decide which of these things you can address, and then you think about how. And so you start with thinking, and then you start scribbling, and then you start looking for solutions. A lot of talking to people who has experience and interesting ideas. And then you start writing and language design.
Right.
Grammar, semantics, kind of stuff.
Yeah. So in my past I had a lot of Lisp in the form of Emacs Lisp. I was quite the Emacs user. And my master thesis was in a specification language called VDMSL, which is a very high-level language. And both of these languages taught me a lot. Not that I want to go back to all the parenthesis errors in Lisp or unbalanced parentheses, and there you are.
Yes.
But I still find it interesting learning new languages, just to see how they see the world different. Which leads to my question is, if you were to meet somebody and tell them, hey, you should go back and play with this ancient programming language, not used anymore, but it had a fun, different approach to it. What would you suggest?
Try Snowball 4.
Snowball 4.
It's completely matching things. It doesn't have a for loop.
Wow.
Yes. It's not a language people know.
Right.
So it taught me one thing. Never, whatever you do, you start writing in the new language in the style that you're used to from your old language.
Right. And
that's something you have to get over.
Yeah.
Because you have to use a language for what it's good at.
Exactly.
And far too often people compare languages by looking at what's good in my language, and it doesn't look good in the other language, therefore my language is better. This is a very flawed logic.
Yeah.
A friend of mine, Andy Koenig, did an interesting experiment once. He took some C++ examples and rewrote them in ML.
Okay.
And then he took some ML examples and rewrote them in C++. Both of the rewrites were awful.
Right. ML, that's a functional language, right?
Yes.
Yeah.
The lesson is the same as what I learned from Snowball, trying to write algol in it.
Yeah.
Doesn't work. You have to learn the way the language was meant to be used. You have to learn the idioms. Then the code becomes much cleaner, becomes more efficient, more understandable.
Right. And that has been both the blessing and the curse of C++, that it has the C ancestor, and like we still have goto in C++ for, I mean, that's not a key word you find often these days, but can still mislead people.
But you need it. If you want to generate code that's optimal for various things, then goto is really good. Okay. As Ken Thompson says, if you know where to go, goto is a way to get there. Most of the time we don't know where to go. We're doing a loop, that's not what it's for. We're doing a virtual function call, that's not where it's for. We don't actually really want to know where we're going. We want it just to be right. But so the last time I used a goto was machine generated. It generated a program, and it was something to do with state machines, and I always knew exactly where I was going. And C++ is, among other things, used as a target of code generation. So
one of the things that I have heard you say many times is that one of the qualities of C++ is its stability over time, that things don't break. And somebody who comes from a Qt3 to Qt4 time frame where everything was broken, even not just on a syntactic level, but on a semantic level too, I certainly can appreciate that standpoint that things shouldn't break. But that, first of all, I wonder, has you never been in a situation where you had to break something, at least recent, I guess, in the first weeks of C++ you did, but up in more modern time where you broke something? And the follow-up question to that is, how do you ensure, with all these millions and millions different of use cases, there's got to be somebody abusing something really dramatic that you'll break?
Yep. It's a real problem. It's always been a real problem. But I found that from the day you get a user, you have a responsibility not to destroy his code. Especially if your first user happens to be your boss, which he was. Sandy Fraser, really nice guy, and actually writing stuff for error handling in local area networks.
Okay.
So I think that's the very first application. That's not a test case. It's
Right.
yes. I spent a lot of time at Bell Labs doing things that was either network related or the kind of stuff that the mathematicians couldn't do because the distributions were too irregular. They first thought that sort of writing simulations were sloppy, and then they realized there's things you can't do properly with mathematics, and so well, I turned out to be reasonably friendly and reasonably competent, so I helped them do that. So that was what I was doing. So from that long time back, I valued stability, which people usually call compatibility, but stability is the important thing, and you don't have to be 100% compatible, but in fact you usually do. We tried to deprecate things on several occasions with C++, and it always failed.
Okay.
People went to the implementers and says, I won't deal with you anymore if you break this code. And sometimes it was really, really small things. Right. We had a fairly successful thing that took many years, which was to get some of the trigraphs out of the fundamental way of representing the code. And the reason was, it turned out that IBM used one of them in every bootloader they had. So if we took that one character out of the language, every IBM machine on Earth would stop working. Right. Nobody would have guessed that. Right. And nobody knew it except we had the IBM rep on the standards committee. I still work with him, Mike Wong, but now I work mostly on safety issues and automobiles.
But this is 2000.
Well, so you get into this situation where the language gets bigger and there's endless obscure things and people get lost. And so at least for almost 20 years I've been trying to find solutions for that. Because, well, you've got a problem, so you have to go and look for solutions. And I think the solutions are guidelines. You say which part of the language you use for what. And then you try and be specific about that. Then you realize that doesn't scale. People can't follow guidelines that are detailed and good enough to be used. So you need ways of enforcing the guidelines. And so first we got to the C++ core guideline, which was a joint project with several organizations. I mean, could you imagine Red Hat and Microsoft sitting together designing something 10 years ago?
No.
Well, it happens. Still happens. Anyway, there we had the rules, and then we had to have the enforcement. So we had static checkers. And if you use Visual Studio analysis, you're using exactly that. If you're using Clang-Tidy, part of Clang-Tidy is that. It's the rules we designed, among other rules they have, but that's the approach. Now, it still doesn't work well enough, because people don't want to use separate tools like static analyzers, like Clang-Tidy, like the one Microsoft, and they're not standardized. So the Microsoft guys enforced some of the rules, and Clang-Tidy enforced a different set of rules, so you couldn't move things around. And so we get to the next level where we define what's called profiles, which is a well-specified set of tests that can be enforced. And that only works if you can first extend the language with libraries and things like that. I call it the subset of superset facilities. First you extend the language to get a more ideal language, and then you cut away the stuff that will create problems for you when you want to get guarantees and have maintainability and such. And the things you want to cut away are almost always the low-level things that everybody depends on. It's pointers, arrays, casts. You can't just take it away before you have extended the language to have alternatives.
Right.
So you extend the language with vectors and spans and things like that. And then you can say, don't ever subscript a raw pointer because you don't have sufficient information to do a range check.
Right, right.
So these days you can actually get Apple and Google, Microsoft, probably others, have what's called hardened libraries that does range checking. And so this is good.
Yeah.
But again, they are not standards. You can't get it out of the box. And nothing stops people from doing the stupid thing like subscripting a raw pointer where they can't check. Right. Because they lack the subset of part of the superset.
So,
but we're getting there. You can get a lot of it today.
Unfortunately, you didn't have 5 hours for your presentation today, so we didn't get much into the profiles. So I'd like to dig a bit into that to see if I understand. So profiles is going to be in the language itself. It's not going to be an extension like Clang-Tidy and...
I hope so. Yeah. I had hoped to get the framework in and the syntax into C++ 26, and I had hoped to get a couple of the really simple profiles in place, like initialization. Don't have uninitialized things. Range checking. Yeah. Don't subscript the raw pointer. Right. I didn't get it in.
So this will be...
it's being implemented.
Right. So this will be an addition in the compile run that I just compile my stuff and I have annotated my C++ files that I expect this written here to be not dereferencing pointers or...
That's right. You want to say, I want the ranges profile, which means that you get a hardened library, which means that if you use a range or a view or a vector, you get range checking. Yeah. And it says, then statically check that you don't do any of the things you shouldn't, so that the guarantee is that there won't be any range errors, as opposed to there's no range errors if you use my library, which you can do today. And it's, by the way, it's an extensible framework. I've heard educators ask for specific things to help them teach their students so that they don't go on the web and learn the wrong thing and then use it. And I've heard real-time programmers want things to do with real-time. And again, you shouldn't expect that in the standard. The standards will be focused on time checking in the most general sense, like don't have a resource pointed to by a raw pointer, use a handle, things like that.
Going to be interesting in the face of Qt, those with all of our raw pointers, but we'll get back to talk about Qt.
I know some of Qt. I mean, Qt goes back to the 90s, and a lot of this wasn't known, and object-oriented programming using pointers were the fashion.
Way to go, yeah.
And people didn't really understand constructor-destructor patterns.
So, as viewers of my previous stuff on YouTube knows, I like to bring my daughters into the play here too. And I asked one of them if she had any questions for Bjarne once I met him here. So here's a question, Bjarne.
Hi Bjarne. I just completed an internship where I used QML. It was very fun to try programming. It was my first time programming, And I would like to ask if C++ is a language I can use, or like young people like me could use for programming.
Yeah, that's a hard question. Let me first of all say, I know there's teenagers and even younger that has learned to write C++ successfully, and it's very popular among people doing programming competitions, and that also happens a lot in high school. But I have not done it personally, and it's not something I'm an expert at. Again, different languages have different strengths, and C++ is not the easiest language to learn because it's built for hard task for engineering. And Gilde van Rossen, who's a nice guy, did Python so that everybody could program.
Right.
My answer is, well, I don't want everybody to program my brakes in my car or my camera, and I'm aiming at a different target. So I have taught C++ to first-year students in university, half engineering, half computer scientist. And so I've taught, 10,000 maybe. So some large number. I've tried this.
Yeah.
And it can be done. And I tried having other people do it, so it doesn't just have to be me.
Right.
Because things don't scale if it requires a single individual. And so I wrote a book, which is lying there on the table, which is aiming at teaching programming for the beginners, but they are first-year university students rather than younger. I have not tried this. I'm very nervous about saying things that I can't back up.
Right.
But anyway, this can be done for first-year students. And it is geared for it. It doesn't teach all of C++, and it goes relatively slowly forward. And it teaches things that you don't usually learn in a first class. Chapter 5 there is about error handling.
Yeah.
Because sure, you make errors, and a teacher should recognize that.
Your users make errors.
Everybody makes errors. The other thing that's peculiar in this one is that pointers are introduced in chapter 17 after graphics.
Okay.
You can do it.
Yeah.
Of course, you can only do it if you have abstractions like vector and string available, but that book does it. That book there, your listeners would, or viewers would appreciate that the graphics bits are Qt based.
Yeah, cool. So yeah, I brought it because my daughter just got confirmed, and I asked her obviously what she wanted. Say, can I have one of Bjarne's books so I can get an autograph version for it? So we'll have to take an autograph here, even though she might have to wait a few years. Yeah. So, but that of course leads me to the next question. If C++, young kids, they want to learn. Maybe not you, because programming wasn't as evolved when you were her age, but that was about the age that I started programming myself. Back then we were doing Visual or COBOL 80 or something like that. But if C++ is not the answer for the first programming language for somebody, do you have any suggestions of another language? I know you don't want to go into language wars, but...
Not really. There are, currently Python is very, very fashionable.
Yeah.
I don't know what it'll be in a few years. In that book I say this is a book for people who would like to become engineers or developers.
Yeah.
I tested it out on hundreds of engineers, so engineering students. So at least I could say that and know what I was talking about.
Yeah.
But
you
really need to distinguish between different groups of learners. I think the wannabe engineers, wannabe, say, doing bioinformatics and such, has one kind of teaching, and and C++ is not an unreasonable choice. Then there's people who want to write web apps, and maybe we're talking Python or JavaScript. So that's another thing. And then there's scientific programmers who basically want to do matrix algebra and advanced algebra and such. But I really think we have to fracture the teaching of programming, because the idea that there's one kind of programming for everybody and that is the best thing for everybody and there should only be one set of beginning classes, I think is wrong. I was out invited at Stanford Education Department, and I was explaining that, and it hit the news. I mean, apparently that was new to a lot of people, the fact that I was claiming that our field is not a unified field. Right. There are different needs and different skills. And
well, I'm one of the things that having a teenager at home growing up that I realize is that abstraction is not something that comes naturally to newborns. You need to, it's something that grows, and I mean, C++ is strong on abstractions and concepts that you need to understand. And if you cannot cope with the concept that you have a vector of different things, then it's going to be an uphill battle.
That's right. I mean, my background is mathematics and history, but the relevance here mostly is the mathematics. Yeah. And so I do understand something about abstraction and how to do it. And I also know that I'm not a great mathematician, so I would not teach mathematically oriented advanced programming. Other people can do that better.
10, 15 years ago, tools like Clang-Tidy, as you mentioned earlier on, was unimaginable. It was science fiction that you had that kind of level of traversing AST from almost a non-compiler background. You seem to disagree there?
Oh yeah, I'm disagreeing.
Okay.
Together with Gabby Does Race, I built a representation of C++ that could handle a superset of C++ actually. Okay. It could do concepts even then. Yeah. Every type had a type, for instance. Mm-hmm. And that was in 2017, so you said 15 years, so yeah. I can disagree. And it was written so that we could traverse programs, do everything and more than you can do in Clang-Tidy. Right. And we were aiming at analysis for safety, resource leaks, parallelization, all these kind of things can be done really well if you have a good representation. And then we're going to go on further to program transformation. Mm-hmm. So I did an experiment, for instance, where we looked for loops that didn't have side effects, so that I could vectorize them right off the bat. And I had another student that was working on removing all the macros and turning them into things that had proper scopes and such. And we're doing things like looking at code, existing template code, and figuring out if there was underlying concepts that we could deduce and then introduce. And as I said, this was 2007, 2008, so it wasn't. It was neither science fiction nor unimaginable, because we did it.
Fair enough.
And we need more of it. I have been quite unhappy with the relative slow pace of this. Right. By the way, you can get that representation. It's called IPR. Okay. Not very imaginative languages. what is it, internal program representation.
Okay.
Very, very advanced, right? And it was only about 2,500 lines of code and could handle all of C++.
Okay.
And it now is the backbone of modules at Microsoft because Gabby is there.
Yeah.
And and you can get it on GitHub. Just put IPR or Gabriel Race in, and you will find it.
Mm-hmm.
Open source,
Yeah.
of course. And there's an IFC, which is a binary version of that, which Gabby and friends did at Microsoft, which again can be used. So it's there.
Well, if I need to stand corrected, being corrected by Bjarne Stroustrup is not the worst thing that could happen to me then. But my question, that it was really just the lead up. So if you look 10, 15 years into the future, what kind of tools do you see that will have hopefully more static type checkers and so on in the language and your profiles that you talked about?
It's easier to look into the past. I just had to disagree because I worked at it, and we would have been further, but we left academia, both Gabby and I, for a variety of reasons. I needed to get closer to my grandchildren, for instance.
Yeah.
Looking into the future, I still haven't seen what I was working on in the past. We're going to get some better concurrency support.
Mm-hmm.
My PhD was in distributed computing and concurrency. And we will get better static analysis, and both representation and tools need to improve. And once we get analysis, eventually we will get into program transformation. Mm. We will also need those tools to be applied to analyzing things for errors and for simplification. Mm-hmm. And we're working on static reflection.
Yeah.
I'm not a great fan of dynamic reflection, Java style, because you turn programs from having an abstraction in the code verified by the type system, optimized with the type system, to being a graph walk with the kind of bugs you get from that kind of stuff. But we have work done mostly by David van der Voorde from ETG for doing basically static reflection, being that you can write code in your program that can look into the compiler's tables and see what properties types have and then use them. So if I wanted, say, a JSON optimized for 3 different types or something like that, it can be done in the language without any data structures. It has to be walked at runtime.
Right.
We're going to get that almost certainly in 26. I would like to see functional style pattern matching.
Yeah.
But again, this was something I did a library 10 years ago that could do it, and the standards committee couldn't agree on what was the right thing to do in the language, and the current design is, in my opinion, inferior and somewhat bloated.
So just for those of us that doesn't entirely understand the whole concept of pattern matching, we're talking about today you can do switch over one variable, you can do switches over multiple expressions even, and
you can sort of say if we have 2 elements and the first one is a string and the second one is an integer, we go there. Mm-hmm. If they're both integers, we go there, and if they don't match one of those 2, they go there. Things like that, and you can do things for types.
It feels a bit like what you do with visiting in variance.
Yeah, but it's much it's more elegant, and and potentially more efficient. I gave a talk about it and gave a presentation some years ago, so it's not as new as people think. I mean, people used to think that object-oriented programming was new, but Christian Nygaard basically invented it in 66, 67.
Right.
So there's a difference between what you can do and what you can dream about. And if you, like me, like to dream with some experiments to back it up, then that limits how far out I'm willing to dream, because I'd like to see that it can work. But yes, and you can switch on types. When it's this called inspect in Simula, so they had it in 67. But if it's a circle, go that way. If it's a triangle, go that way. And you can do many other things with types. You can switch on values and types.
So getting back to the reflection, that's we are here at Qt World Summit, and reflection, the dynamic reflection, is one of the fundamental things in Qt. Came with the birth of Qt. That Qt was even born out of the master thesis or PhD for one of the founders, being able to do the signal slot mechanism and so on. And I understand that where we are today, 2025, that's a different place than it was in 1990 when that work started. If they had met you back then, what would you have suggested? Would there have been a different path? I mean, you can't argue with success, as they say, and Qt has been a very successful in its industry for 3 decades now.
That's right. I mean, I wouldn't claim everything in C++ is right. I think I got the major things right, and every detail could be improved in retrospect. I never was a fan of meta objects, so the mock I wasn't a fan of. I saw it somewhere in the 90s, and I didn't like it then. On the other hand, signals and slots are wonderful. And today you can call it without violating the type system. And if I had known how to do that then, so that I could get connect without having to run through generating a meta object, then I would have recommended it. But one, I wasn't asked. Two, it wasn't my field.
Right.
And 3, similar things crops up elsewhere where you want to generate an object map of something, either runtime, or you generate the code that basically the code embeds the type resolution that you can get in static reflection today.
Right.
And so if I had to make a conjecture, then you would be able to next year build a Qt without a mock, with all the features I know of Qt, using static reflection and the current overloading mechanisms and such. Now, I'm not a Qt expert, so an expert could probably find a hole in what I just said, but it's not a bad conjecture. That would make things a bit faster, a bit easier to maintain and such, I think. But again, I haven't done it, so take it for what it is. And I couldn't have done that 15 years ago.
Right. And sometimes it has been celebrated here at Qt World Summit, the 30 years of Qt, and it was even 5 years before that they started. So it's same order of magnitude, give and take, with C++. I mean, C++ must be 10 years older.
It has to be, otherwise they couldn't have implemented it in.
That is true. So, yeah.
But I was focused on something else. that very dynamic stuff tended to be dynamically typed and sort of small talk like. And to this day, Qt has too many objects that has to be on the free store, and it's.
Yeah.
I mean, I hear that the new Qt vector maps to a list, but lists are very slow. So that kind of stuff I would have been unhappy with.
Right. Well, fortunately with Qt 6, there was in Qt 5 early on there was QList and QVector, and QList tried to be smart, so it was a skip list kind of thing of vectors, and vector was just stood vector basically. But these days they threw away the QList altogether, and now it's just an alias to QVector. So at least they cleaned that up.
Good.
So,
I didn't know that, and I'm happy about it.
Yeah, absolutely. In your presentation, you talked about modernizing your C++, and that you needed to go with the modern set of C++. But how do you see? I mean, I asked that's our family's good friend Gemini, because my kids will ask me the weirdest question. I was like, why don't we ask Gemini? And I'll take my phone out because I don't know everything either. So I asked which toolkits and frameworks and libraries that existed that was 30 plus years old in C++ and are still alive and kicking. There wasn't all that many of these. So I wonder if you have any suggestions for both Qt itself and Qt users, and how do we gradually modernize? We have not as many users as C++, obviously, but still.
I should probably not answer that question because I don't know enough about Qt, and I don't know enough about the users of Qt. So I can only give a very general answer. So, for instance, you have a lot of raw pointers, which I consider a problem, and has in various places been a solvable problem, switching to unique pointer and sometimes shared pointer, and getting safety, resource, absence of resource leaks and such out of it. If that can be done, then that opens the way for dealing with exceptions. Exceptions should not be used for everything, but there is a lot of errors that doesn't happen for every run, for every week, for every month. And that kind of errors should be exceptions because they are exceptional. And so, but as long as your code is a rat's nest of raw pointers, you can't do that. On the other hand, I see no real reason why there wouldn't be an import Qt that hides some of the complexity behind a wall. You'll have to address the problem that modules don't do macros. But what little I know, again this caveat, I think you could handle that. And you have a single source of everything, which is the Qt company. Therefore you have control, and you can make changes, you can enforce changes on people, you can have the things that you can't do in the general C++ community with multiple tool chains and multiple, really multiple industries with different needs. So I think you could do better containers, better pointers, and I think you'd like modules. Everybody likes modules because, well, they don't have to go and get coffee each time they compile.
So, well, that is going to be a difficult problem if you can't run off for coffee while your compiler is running. But
I have a coffee machine on my desk. I don't have to run anywhere.
You have answers to all the problems. So the final question when it comes to import Qt, and I'm wondering, do you have any experience of how much does it take to rewrite your software to modules versus, well, non-modules in non-hello world kind of applications. I mean, STD has been rewritten. That's not trivial, I take it.
It is not trivial. Something like STD, I think, took a couple of months, and there was a couple of bugs that had to be kicked out.
Yeah.
And I believe it was roughly one person. So there's a few 100,000 lines of code. If I make a wild guess, no, I should not make a wild guess, because modularizing depends critically on how well organized your code is.
Mm.
If it uses a lot of macros that you can't get rid of, or that you have to reorganize to use const expr and generic programming, and if that's not what you've been doing, then it's a lot of work.
Yeah.
If you're my code, which doesn't do such things, basically I stick an include mycode.h inside a module declaration, and then I run. That's it.
Yeah.
Now we're talking a minute.
Yeah. So
it's somewhere between a couple of months and a minute, and that's why I shouldn't make a wild guess.
So if Qt is not, for one reason or the other, going into that, I can do import Qt, but I still have a reasonable sized application split up in multiple libraries. Will I gain anything, or will the first time it include something after an import? The preprocessor will be kicked in anyway.
No. Yes, the preprocessor itself doesn't cost too much.
Okay.
It's the way you use it. And you can mix imports and includes. Yep. And we do.
Yeah.
I've seen many people do that. As a matter of fact, if you import something that has included a header file, and then you include the same header file again, it works.
Okay.
So there has been a certain amount of effort put in to make sure that the old stuff will work with the new stuff. We always look at that in the standards committee.
Yeah.
We would like to use the new stuff, but we can't go and break everything.
Right.
And that includes things like the tool chain quite often, because we have the implementers there. So,
well,
look, if I was Qt, I would try. That's.
Yeah.
But there's no guarantees.
Right. But there is their fair share of macros. There's obviously the whole Q_object macro, but that's for mock, and we can do without that in a future. And then there is all the Qt has been they tried to make it possible to cut down Qt as much as possible for embedded devices that do not have a keyboard, for example. So they have this, if there's no keyboard on my device, then do not compile these lines of code. And those is going to be difficult. Or there's another one, my favorite one is Qt no cast from ASCII. So you have your regular Q label, it takes a Q string, there is an implicit conversion from char pointer to Q string. And if I give that char pointer to my Q label, then it will cast, unless I explicit that one.
I've noticed. But I'm not an expert in Qt, and I should not go any further about these things. It sounds to me as what you're saying are solvable problems.
Yeah.
But I would be a fraud if I suggested a solution based on the little I know.
And let's end with these words of hope that one day we'll be able to do import Qt, and we'll all move our coffee machines closer, so we don't have to run for the coffee. Bjarne, it was an absolute honor to have you. Thank you very much.
Okay, thank you.